So in this lab, you will do 3 different chemical reactions. You're going to write down the chemical equation, mole ratios, and stoichiometry for all the 3 reactions. So when you do a reaction, for example, you will mix chemicals, you will mix 2 chemicals, and whether the reaction is taking place or not, it depends on what you observe. You will observe the reaction, you will observe the reactants, means before you mix them, what happened during the reaction, and how your final mixture looks like. Now, there are 4 common indications of a chemical change. Formation of a solid. You will see your reaction mixture is opaque. It means not clear. It's like not transparent. It will be cloudy, or you will see some solid particles. Or formation of a gas means you will see bubbles. Temperature change, and before and after mixing, your test tube is either getting warm or cold. Color change can be a indicator for a chemical reaction or cannot be. So this is one example I'm giving you, and I'm showing you all the work, and that's what you have to do for the 3 reactions. For example, magnesium metal with hydrochloric acid. So you take a test tube, in that one you put a magnesium metal, and on that, when you put a few drops of hydrochloric acid, you see what do you observe? You see the bubbles. So under observation, I'm writing formation of bubbles. And then I will also give you the information saying, okay, magnesium reacts with hydrochloric acid to form magnesium chloride and hydrogen gas. So if this information is given, so magnesium metal, so you write down S in the parentheses, solid. Hydrochloric acid formula is HCl, aqueous. All acids are aqueous. To form magnesium chloride. So I'm expecting from students to know the formula for magnesium chloride, because we learned in chapter 3 how to name the ionic compounds. And hydrogen gas, again, hydrogen is one of those 7 elements that exist in diatomic form. So you're writing the equation first, here where it says molecular equation, and then you're going to write down your balanced molecular equation here in this line. Then there is a table under this mole ratio. So what is the mole ratio? If you look, 1 mole of magnesium atoms combining with 2 moles of HCl molecules to produce 1 mole of magnesium chloride and 1 mole of hydrogen gas. So this is my mole ratio that I found it from these balanced coefficients. Then the next thing is I have to convert these moles to atoms or molecules. 1 mole here for magnesium atoms means how many atoms? Avogadro's number, so 6.022 times 10 to the 23rd. So if I have 2 moles, that means I have to do 2 times Avogadro's number. 1 mole Avogadro's, 1 mole Avogadro's. So here I converted my moles to atoms or molecules. Now in my third row, I'm going to convert these moles to grams. So magnesium atomic mass is 24 AMU if I'm talking about an atom. But if I'm talking 1 mole of magnesium atoms, so 1 mole of magnesium atoms means 24 grams. For HCl, I will take mass of hydrogen atoms in grams. 1, chlorine is 35.5, 1 plus 35.5 is 36.5, 36.5 times 2 is 73. For magnesium chloride, magnesium is 24, chlorine is 35.5, 35.5 times 2, and then when you add, you get 95 grams. And 1 mole of hydrogen, 1 times 2 is 2. That means 24 grams of magnesium reacts with 73 grams of HCl to produce 95 grams of magnesium chloride and 2 grams of hydrogen gas. Then, once I'm done filling this table, I have to answer the last part. Choose the best option. Is this a single replacement, double replacement, combination, or decomposition? So in this reaction, basically what is happening here, magnesium is replacing hydrogen from HCl and is taking its place, combining with chlorine, and hydrogen is kicked out. So then I will circle this single replacement reaction. So what you have to do is, so this is already done, so you don't have to do anything in this. This is just an example. Your first reaction will be, you will take iron, which is the steel wool, in your, and then you will take a small piece of iron wool in a test tube, and you're going to add a few drops, let's say 4 to 5 drops of copper 2 nitrate solution into it. You observe the reaction, little bit stir it or shake it, and you don't have to observe it for 5 minutes, 2 to 3 minutes are enough. Then you write down your observation here. Then I give you a statement here. You change this into an equation, put it here, and then you balance the equation. Once you balance the equation, then looking at the balanced equation, you will complete this table and then circle one of them here. So that's your first reaction. For this you need iron and copper 2 nitrate. So your second reaction will be, take a test tube. In that you will add 4 to 6 drops of NaOH, and into that you will add 4 to 6 drops of copper 2 nitrate solution. Shake it gently and then complete this. For reaction 3, you will take calcium chloride solution and add a few drops of sodium carbonate into it. Shake it well and complete the table. Once you are done with all 3 reactions, you're going to upload this lab report. It's 4 pages long under the file that says upload lab 5 report here.